Hi everyone. I hope you're having a good Monday and I hope your weekend went well. I hope that your family is safe and healthy. Please make sure to keep washing those hands, keep staying socially distanced whenever possible. Take the warnings from the CDC seriously. I'm going to revise some earlier statements and say that I don't really see us going back to school at all at this point, at least not this school year. I'm guessing that all this, based on current data, is going to peak somewhere in early May, maybe even mid-May, which means it wouldn't be a good idea to gather with people at that large a gathering until probably the end of June or even later than that. I'm sorry for what this means for everyone, but what it does for school is that probably all these grades are going to be used to justify giving you credit for these classes for the rest of the semester. The Georgia Board of Education did say that Cobb County and other school districts can give credit for classes done through different means. They've removed the seat hour requirement, which means that you can get credit for physics as long as we keep doing physics. I'm sorry it took me so long to get that test up, but hopefully, now that we know what we're working with, I'll be able to arrange everything else to be easy and straightforward online. Make sure you're able to contact me through Remind so that if you have any issues, you can let me know. And as always, if you're having any trouble regarding food, shelter, or cleaning equipment, cleaning materials, please let me know so that we can make sure we address those issues. Today we're talking about the atom. We're moving on into nuclear physics. That'll give us a nice 1 week lesson, 1 week unit, I should say, before we get to spring break. So let's start with the atom. Let's take a look at the atom. The atom is made up of three subatomic particles: protons, neutrons, and electrons. The protons and neutrons reside in the dense nucleus of the atom, the very core of the atom. There, they make up 99.9999999% of the mass of the atom. Almost all of the mass is made up by protons and neutrons. In a cloud surrounding the nucleus and making up the great majority of the rest of the atom, in terms of space, we're talking 99.99999% of the volume of the atom is made up by the electron cloud. Electrons have a -1 charge and protons have a +1 charge. Neutrons do not have a charge. Notice that if we add a proton, that now we have a different element. Protons determine the atomic number, which determine the element. We've gone from hydrogen to helium on the periodic table here. If we add a neutron, we're instead changing the atomic mass alone. And if we add an electron, we have changed the charge to become more negative. Let's take a look at this on the periodic table. Here we have a helium atom. Notice it has an atomic number of 2 because it has 2 protons. And it has an atomic mass of 4 because there are 4 subatomic particles in the nucleus, 2 protons and 2 neutrons. What will happen if we add a proton? What will happen to the atomic number? It will increase by 1. What will happen to the atomic mass? It will increase by 1 because the atomic mass is a count of all the subatomic particles in the nucleus. The other thing that will happen is that we will now have a +1 charge. This is a +1 ion because we now have 3 positive charges from the protons and only 2 negative charges from the electrons. I'm going to switch over to the Bohr model, which is inaccurate, but it makes it a little bit easier to see the number of electrons. In order to make this more stable, we can add in a neutron. Notice by adding the neutron, we've increased the atomic mass, but not changed the atomic number, and thus we still have lithium. Here we have a neutral helium atom. What happens though if we add a neutron? Now we have an unstable isotope. An isotope is the same element but with a different atomic mass. So this would be helium-5 because it has an atomic mass of 5. This is helium-4, helium-3, helium-2. Notice that helium-2 is unstable, helium-3 and helium-4 are stable, and helium-5 is unstable. That means that helium-2 and helium-5 are radioactive isotopes because they will undergo radioactive decay. We can do the same thing with carbon. Let's see if we can get up to carbon. Carbon-8 is unstable. Carbon-12 is stable. And you'll notice that if you look at the periodic table, the most common atomic mass is 12 for carbon. You'll notice that the atomic mass is 12.011 on the periodic table. That's because that's an average of all the atomic masses of all the carbon atoms in the world. Most of those are carbon-12, but there's a good bit of carbon-14 in the world. Is it stable? No, it's unstable. It's radioactive, and it will eventually turn into a different stable element. But we have to average all that carbon-14 in with all the carbon-12. But which one is there more of, carbon-12 or carbon-14? Well, since the average is 12.011, that means there's a lot more carbon-12 in the world than there is carbon-14. That's it for today's notes. Please make sure you check Canvas for the assignments and have a wonderful day.